Let's see. Can you guys hear me? I think it's a going. I think it's going. Let me get this guy going. Yes, ooh, wahoo. Okay. Can I rotate this? I haven't opened up OBS in a while. It's been a bit. Okay, wait. I can do this. I can do this. No, that's not how you do this. Sorry about the Twitch thing, by the way. When I go to my Twitch creator dashboard or whatever, it says like I didn't notice there's a tiny thing in the corner that has like a count. So I think I technically am streaming, but the video player where it's supposed to show me streaming is just empty. So I don't really know what that's about. There we go. This is what I wanted. Clockwise. Yeah. There we go. Only the highest quality phone video. Amazing. Okay. Now I can put myself over here. Okay. So you could tell what's going on from the title, I think. Hopefully that was clear enough. And the first thing we have to do is an unboxing, and I can't show you the box because it has like my name and stuff written on it. Let's go open the box. Let's go get the goods. I don't have scissors. How am I this bad at planning? It's okay. I have a wire. I have so many things that could be scissors. Oh, I have a key. I can just use my key. There we go. Perfect. Bag of rock. This is some. I forgot this was in the frame. This is some bismuth metal that I got for a future thing. You can actually see it. Looks really pretty. There we go. And then it has like the oxide sort of coloring on the top. It's obviously not like the pretty crystal ones. And then it's shiny on the side because this was like just cut or melted or whatever. I think it looks really pretty. So yeah, I have a pound of bismuth now. I don't like non-metric units, but that's how they sold it to me. So I have a pound of bismuth. Oh, some of it got somewhere. Oh well. Maybe I'll be eating some bismuth today. It's better than eating some lead, which is this bismuth, as most bismuth, is being used as an alternative to lead that won't poison me. Yeah. Because the bismuth's atomic symbol is Bi. I guess maybe after doing some gender fluid chemistry, we can do some biochemistry. That'd be pretty sick. Okay, let's get this box open. And then I can reveal its contents. Alright, I want to make sure there's not like a packing slip or something that gives everything away. Okay. There we go. We have the box. And inside the box. That's baking soda, sorry. Alright. Inside the box we have dramatic flourish. It's so good. We have the gender fluid. I gotta get this open. I think we only need 3 different colors, or that's just the other side? I think that's just the other side. Oh, it's perfect. It's so perfect. This was totally a good way to spend way too much of my money. It's so good. I don't know why I packed it so tightly. But there it is. Oh, it's awesome. It's so good. I don't know what to say. Lavender and lemon, yeah, blah, blah, blah. And then it has some stuff on the back that's just like defines gender fluid, I guess. And there's some nutrition facts and some ingredients, and the ingredients are important for us. So we have sparkling water, which is just carbonated water, natural lemon, lemon and lavender extracts, okay, and then citric acid. Lemon also has a lot of citric acid in it, so there should be a lot of citric acid in this. And if we can extract the citric acid, then we can, yeah, exactly. Bismuth is not toxic too. If we can extract the citric acid, then we can make other salts of citric acid, which it turns out are used as basically emulsifiers, but it's used to make cheese smooth. So that's the general plan. I have some cheese. Where's my cheese? Oh, it's still in the fridge. I have some cheese in my annoyingly loud fridge, and we can try to make smooth, like mac and cheese style cheese, with the citric after we turn the citric acid in here into sodium citrate, which is harder than it sounds. It sounds like you just add sodium. Actually, I don't know if you could do this by adding sodium metal. Maybe you could. I don't have sodium metal. We're gonna do this by here's our synthetic pathway to sound fancy. We have some pickling lime, which this is calcium hydroxide. So what this should do is this should react with. There's basically two main acids in this. There's carbonic acid, which is what happens when you have CO2 dissolved in water, since it's sparkling water. Probably a lot of that. So we have carbonic acid and we have citric acid. So when we react them with calcium hydroxide, we should get calcium carbonate, which is totally insoluble in water, or not technically totally, but extremely insoluble in water, and calcium citrate, which is pretty insoluble in water. And so what we can do is basically try to dissolve in water. The citrate will dissolve as long as we use enough water, but the carbonate won't. And then we can extract the citrate, and that's how we get like the citric acid out of all the other stuff. We'll probably carry like some malic acid or something over it, but it's all right. We're not trying to make some analytical grade, lab grade sodium citrate. And then once we have the calcium citrate, then we can convert it to sodium citrate pretty easily with some delicious sodium bicarbonate, which is the baking soda that I have. Yeah, and then we can I don't know, make cheese with it. I might have to go like downstairs to the kitchen to go microwave it because I thought I had a kettle, but I don't, and I have no idea where the kettle went. I don't know how you just lose a kettle, but I guess I did. That's okay though. So anyway, then enough talking about the grand plan. I guess we have to do a taste test, right? We can see how much we're improving it by doing chemistry with it. I don't know. Let's give this a shot. Well, it definitely is sparkling water. You can see the can is so flimsy too. It's actually the more fun science because the carbon dioxide because the carbon dioxide like in here creates a huge amount of pressure. The cans are much you probably noticed the soda cans are much stronger when they're like sealed than when you open them. But there's all kinds of crazy stuff that has gone into making soda cans as like absolutely cheap as possible. To the point where people are like engineering materials that are like stronger and like even though it's just aluminum, a lot of soda cans have like crazy aluminum derivatives that are designed to be stronger in some directions than the other. Because like you can make it a tiny bit thinner if you put your basically it doesn't matter if it's strong in some directions, it matters that it's strong in other directions. There's an insane amount of science and engineering that has gone into like making soda cans like half a cent cheaper. It's crazy, but anyway, now that this has calmed down a little bit, we can test it. Well, that's pretty good, actually. It's pretty good. That's pretty good. I'm glad I spent way too much money on these. Damn, all of that in a soda can? Yeah. Yeah, let me quickly check to make sure Twitch chat's not lagging behind and stuff. Okay. I think it's okay. I think things are okay. So, I guess first step on our adventure is to try and do some calcium salts. So I got some cups. These beakers are for losers who have too much money and resources and don't just use plastic cups. There we go. Cup. I present cup. And I guess we can just. How do I want to do this? Because I probably want to dilute it. Yeah, okay, let's do that. So we'll first pour in some, actually no. I know how to do this. We'll first pour in some test. That's probably a good amount. A little bit more. There we go. Amazing. And we kind of want to get rid of as much of the carbonation as we can just from agitating it, I guess. So let's see what we can do by just doing that. Because we don't really care about the carbonation. We want to get rid of the carbonation. The calcium will help some of that, but not that much. Good. Fizzing is good. We want to hear it fizzing. Ideally, I would use something with more nucleation points, but yeah, this seems like about as good as we're going to be able to go. Again, we just want to not have to bother with carbonation that we don't have to bother with. We're not trying to get rid of all of it. I have a friend who uses oh yeah, that's a classic. That's a classic, using the broken beakers. Let me get one of these coffee filter thingies to rest my cutlery on. All right, now, I think now we can dilute it a little bit. There we go. And then we can add our food grade. Again, all of this is food grade because I want to eat it at the end. We can add our food grade calcium hydroxide. Even some on the back. It actually says, there you go. Actually, I don't know if you can see that. Calcium hydroxide. Where's this hard to open? Okay, there we go. Wait, is it like sealed? So they have a Ziploc thing, but it's like still sealed. Wait, just eat it? How am I supposed to open this? Oh, there we go. Yeah. Delicious calcium hydroxide. They called it pickling salt. Like, I know calcium hydroxide is also used for the process of making tortillas, because I saw a cool video about it. But, yeah, let's go ahead and see what we can get. Oh, this is very fine. That's probably way too much, but we'll figure it out. The thing is, calcium hydroxide is also insoluble in water, or insoluble enough, so it should get filtered out with the carbonate. I don't think there's any super worrying side reactions we have to worry about. But, oh yeah, it's dissolving. There we go. There we go. And it's not really going to bubble or anything, because these reactions aren't releasing any gas. We're just basically swapping around, from hydrogen carbonate, which is just CO2 in water, to calcium carbonate. Let's see. There we go. Delicious. Okay. And then we want the only slightly soluble citrate to still stay dissolved. So what we can do is try to dilute it a bit. That should be good. Not focusing. Oh, you silly camera. Silly camera. Can I lift it up on something? Let's see. I don't want it to not be in focus. That would be horrible. It would be tragic. Tragic to have it not be in focus. Just put it on top of, well, no, I don't want to damage a bunch of library books. That's a terrible idea. Okay. Well, yeah, what's stopping me from using the box? I can't use the box. Can I turn it upside down? I don't want to box myself, but I also... Shit. Well, oh, here, I can use all these books. No, I don't... This is annoying. Normally, when I'm filming things or whatever and I need to mount something, I just stack it on top of a bajillion books. Unless I move the camera to be on top of books, that would work a lot. Yeah, it's fine. I can just hold it up to the camera. There we go. Amazing. You can see it's already kind of separating out. I don't know how easy it is to see that, but there's very clearly like a water layer on the top. So let's leave that now because that will kind of help us filter probably. Let's add a little bit more water. I'm not convinced this tray is all dissolved yet. I'll wait for it to settle and I'll do that again close to the camera because it makes a cool effect when you pour water into it. Mostly separated layer. Alright, there we go. Woo. Whee. And then it separates again. Alright. Now, we filter it off. Filter time. So we can mark it up. We get only the most scientific of equipment, which is coffee filters that I can get for like 200 of them for $2. There we go. I guess technically I could taste it at this step, but I don't really want to. Alright, let's see if I can do this in full view of the camera and not spill shit everywhere. That's good. That's something that's going. Calcium citrate is fairly heavy though, so I'm kind of worried it's mixed at the bottom. I guess I can stir it a little bit, that might help. Wait for it to separate out again. I wonder if I could pour this into 2 cups. That might help. That might help. Or we'll do this in parallel. Looks like milk. Actually, so there's a very similar thing, which is instead of, I think it's the hydroxide, where calcium hydroxide is very similar to magnesium hydroxide. And if you put magnesium hydroxide in water, it's used for some like medical stuff. But it's literally called milk of magnesia. That's like the old-fashioned name. So you're not the only person to think that, I don't know, solutions of alkali earth metal hydroxides look like milk. See if I can get a little depression in the center there. There we go. Well, that's dripping everywhere. That's okay. That's okay. We're actually getting some of the solid too now. I'm going to do another one. I have lots of cups. I have lots of these clear cups, so this is what passes for improving production value on this channel. Is instead of the not clear, the opaque paper cups, we're working with clear plastic cups. It's worse for the environment, I guess, but you can actually see what's happening inside it. That's the great innovations in Xenotime Industries. All right, let's. Yeah, it's going. This one filtered way fast, man. I don't know, it just kind of feels like it is. Oh shit. Okay, well, there might be some calcium hydroxide in this can now, but that's fine. That's all right. Everything is fine. Yeah, I guess we just keep going at it. Why is that first one taking longer than the other ones? That doesn't make any sense. Oh, I think it just looks like it is, but it's actually not. We can go wash this out with a bit of water. Get the last of our product. I mean, not really. There's still a bunch there, but not enough for me to bother with it. All right. think that's good. These are pretty close, actually, so we'll wait for that. Let me see if Twitch has decided to stop being silly. 0 viewers for... Okay. I'm kind of worried that the Twitch thing is, like, super glitchy, but if there's 0 viewers, then no one will no one will know that it's glitchy. It's the perfect crime. Oh yeah, those are dripping. I can hear them dripping. Perfect. Then I'll probably want to wash them a little bit. So I guess I didn't really need to add that much water since I'll be diluting it anyway when I wash them, but that should be fine. That should be fine. So once we get, so calcium hydroxide reacts with hydrogen carbonate and hydrogen citrate, which are just carbonic and citric acids, and that should give us what we want. I'm still kind of worried there isn't enough water to dissolve the citrate. What was the solubility, like 1 gram per liter or something? We probably have like 25 mils here, so we're gonna have like less than 1 gram of citrate. We'll work on it. It was definitely more than 1 gram per liter, I think. That's okay. That's okay. This is definitely not the best way to do this, but it's the only way I could think of doing this where all of the chemicals were easily obtainable in like food safe form. This would be a lot easier if I used Twitch stream's not working on, but that's fine as long as the YouTube one works. Okay, yeah. Someone was saying it was working, but I don't really know. To me, it's not working, and yeah, as long as the YouTube one works, that should be okay. Okay. What was I saying? I got completely sidetracked. I would. Oh yeah. This is the only way I can think of doing it with like easily available food safe chemicals. This would be a lot easier to do with like silver if I could use silver compounds. But first of all, those are photosensitive, or really significantly photosensitive, which means that they like degrade or change form when exposed to light. So you have to do everything dark, which is not great for filming it. And the other problem is like no one sells like food grade silver nitrates. You can't eat silver nitrate. I mean, you can, but like I think it causes like staining problems and all kinds of stuff. So like, this is what we get. We're going by the calcium salt, even though it would be very better to not do that. Let's go try to wash these down now. I think we're getting a decent amount. I think this is working not horribly. We'll have to see, right? We'll have to see if we get any citrate when we cool it down. Do I have a plan for cooling it down? Because I guess I could dilute it, but cooling it down is probably, or not dilute it, boil it off, but cooling down is probably easier. I guess if we, how are we going to do this? What's the plan? Do I have any plan whatsoever? Calcium hydroxide will react to form excess calcium carbonate, which is fine. Sodium. Okay, wait. So what ions are involved? This is how you do inorganic chemistry. You just think about which ions are there. So we'll have probably some residual calcium hydroxide. So we got calcium ions, we got hydroxide ions, we got sodium ions and carbonate ions from when we're going to add the baking soda. Baking soda, it's sodium bicarbonate, but it can reversibly convert into sodium carbonate. They're in equilibrium. Or I don't know if they're actually in equilibrium, but the point is they can convert. They're both basically just different forms of carbonic acid salts. If we have that, we can. The calcium will go react with the carbonate, and we'll have calcium carbonate, and the thing that will be left is hydroxide ions, citrate ions, and sodium ions. So we'll have some sodium hydroxide, which is kind of caustic and bad, and we'll have some citrate. Yeah, wait, no, this is stupid. Why did I do it this way? I think this is bad if I add an excess, because I need a way to get rid of the calcium hydroxide. Oh well, we'll cross that bridge when we come to it. We'll cross that bridge when we come to it. They're trickling down. I'll do one more washing while I try to figure out what's going on. So if I have excess calcium hydroxide, I guess I can test if I have excess calcium hydroxide. There should be a way to do that. If I add more gender fluid, does it precipitate? Okay, so this is good. Our plan's good. We have an amazing, perfect plan. And if the test says that there is none, then I don't know what I'll do, but we'll figure something out. That's what we're gonna do. Okay, everything is fine. I also have some pepper, I guess, if we want to season our cheese. I don't really know. We'll cross that bridge when we come to it. Yeah, I should get the cheese out of the refrigerator. Refrigerator. Where's the cheese? Fuck. No. There we go. There we go. I have obtained cheese. We have cheddar and we have Gruyere because the internet said if you want to make smooth cheese with sodium citrate, you want these cheeses. There's like a bajillion options, but this seemed to be the most common one. I can put this back in the refrigerator. We don't need it quite yet. Come on, you goofy movers. I spilled more of this than I thought I did. There we go. Let me get an extra couple of this in. Okay, that was maybe a little bit of contamination, but it should be fine. The layers are separated anyway. Okay. That should be decent. These actually look pretty clear, so I guess the filtering did its job. Now, what we want to do now, what do we want to do now? What do we want? Oh, right, test. So we'll pour these guys together, but we'll leave a little bit to test with. And then we'll pour our quote-unquote carbonic acid, which just happens to be mixed with a bunch of other stuff. Do we get precipitate? It looks like we get some precipitate. Or do we? If we do, it's not very much. Because the condensate is resolving. So there might have been some excess, but it's not much. Because calcium hydroxide, the thing is, calcium hydroxide is also pretty insoluble in water. So if we cool it down in order to separate the citrate, that should also separate any hydroxide. The problem is hydroxide we don't want, citrate we do want. So I don't know if that's the best. That's going to help us much. We'll see. How do we want to do this? Because it'll... The annoying thing is, like, I don't really have any other chemicals to... Stupid model. There we go. The annoying thing is I don't really have other, like, chemicals to try. Right? I have baking soda and calcium hydroxide, and that's kind of it. That's kind of it. So I think we could just put an excess and then filter it again. I don't really want to filter it again. That seems kind of annoying, but I guess I could. Well, the thing is, this actually looks pretty clear. No, I think this was just... I don't know what that was. But there isn't very much of it. Let's see if we can extract it just to see. We're now very much in just ad-libbing it, just running with the territory, but let's see, let's use the crappier paper cups this time, if I can work my way around them. There we go. Alright, let's see, this is our test subject. I suppose we know a little bit more. Seems like that's fine. Again, this has carbonic acid. This should form calcium carbonate, but it's totally insoluble, and I don't really see anything totally insoluble. I guess I can check. We'll look for anything insoluble there. It has a little bit of acid to it. That's trace. We can call that trace. That's what you do when there's contamination. You don't. When there's contamination, you don't like, and you want to pretend it's not a problem. You just say it's trace. There's just trace contamination. Don't give percentages. Just say it's trace. You know what? I bet I can. If Twitch isn't working, why don't I just stop the Twitch stream? And then, yeah, and then my computer should be less laggy. Okay. So we'll keep letting this filter through. I really don't see any filter, so it looks like we're good on that front. This still is a little bit cloudy, so I might want to filter this stuff again. And more cups. We're really burning through these plastic cups. That's all right. Turtles aren't real. I can't say that. Don't use plastic if you don't need to. These will be recycled. Actually, recycling is kind of often recycling is often thought of as better than it actually is, but there we go. Kind of fold this thing around here. This should filter much faster since it's just. Yeah, see that we need to like do it in simple batches. Yeah. Well, there's some loss here, but whatever. It's alright. We can accept such loss. Huh? Now I can reuse this once that one's done. Coffee filter time. Coffee filter time. Yeah, we'll do this one. Did I put 3 in here? Oh wow. I mean, they're like 2 cents each or something. No, 1 cent each. I think 1 cent each. So it should be that much. Okay. Yeah, I think all this stuff is accomplished. It's just spilling more water absolutely everywhere. But it's okay. Everything's fine. Where did all the water go? Is it still here? Okay. Yes, it is still there. As evidenced by the fact that it spills when I open it. Amazing. Come on, little guy. Come on. Save me. Okay, yeah, so that should be no. There can be some calcium hydroxide there. Calcium hydroxide is fine. Calcium citrate is what we want. Calcium carbonate should be safely tucked away in here, in the depths of our filter. There we go. This is way clearer, actually. Perfect. So this is hopefully calcium citrate solution. I wonder if there's. It does kind of seem like we've lost a bunch of our product, but that's okay. Oh wait, no, there's a bunch right here. I just can't count. I was like, where did it all go? I was only looking in 2 cups when there were 3 cups. Okay, sure. Wait, why did I take the filter off? I could have poured it in there. Oh well. This is fine. I guess I can start putting these in the freezer to cool them down. And then hopefully calcium citrate will precipitate out, because calcium citrate is only slightly soluble in water. And there should be enough citrate here. We should have hopefully saturated it if I did the maths right. Which I didn't, because I didn't do any maths at all. we're kind of vibe chemistrying here, which is should never do, but since it's all food safe stuff and I know enough of what I'm doing to do it safely, then we're fine. How expensive was the gender fluid? It did too much, but not enough for me to not buy it. They're like $4.99 for a thing. So yes, it's a stupid amount of money, a very, very stupid amount of money for just sparkling water. That's flavored. But funny. and I don't know, maybe I'll get like 2 cents. Fuck. Well, there goes like 30 cents of gender fluid on right onto the wall outlet. Amazing. Um, yeah, right. Like it's too good. It's too good. I guess I can drink more of it. This is the one that might have some calcium hydroxide in it. Mm. I can't taste any calcium hydroxide, so. See, that's what's great about doing quote unquote chemistry when it's basically just cursed cooking. Is everything you're working with is food safe and everything you're making is food safe and all the intermediates are food safe. Then it's like, is there citric acid in here? Normally you'd have to run a GCMS or whatever. That takes a long time and uses expensive equipment. No, I can just taste it. Does it taste like citricy? It's perfect. Who needs a GCMS when you have your own God-given my hair? You have your own God-given GCMS. Well, it's not really GC, but it's not really MS either. Okay, your own God-given analytical equipment. I'm gonna do the filtering in parallel because this is taking too long. It was too long. Oh, wait. The thing about my threshold, the thing with the stream is that as long as this goes better than the last time I tried to do food-related chem, which was the tofu stream, I'm happy. That's the bar, and it's a very very low bar. Am I already getting flashbacks to that? No comment. I will not. I will not disclose whether or not I'm getting flashbacks from that. There we go. I think we are actually filtering out some. I think we're doing good. I think we're doing good. Our increasing the purity of our extremely pure citric acid, which probably also contains what? It contains malic acid because lemons have that. There's probably basically a bunch of random stuff that lavender has, and lemons have too. It's not lemon juice. Amazingly, is not just citric acid, malic acid, and that's it. It's hard to believe, um, but it's not. It's not. I mean, I don't know. Maybe it is. I haven't run an actual QCMS on it. Maybe it is just that. All right, are these going yet? They're going. They're going. They're filtering. We're getting a good amount. Is calcium hydroxide more or less soluble than calcium citrate? Let me look it up really quickly because this would be good to know. Calcium. Shit. Oh, my computer's really slow. Calcium hydroxide. 20 degrees Celsius is 1.73 grams per liter. Okay, calcium citrate. Oh, it's less soluble. Wow. Calcium citrate is 0.95 grams per liter. That's really not soluble. What was my plan here? What was my plan? I'm going to have like a couple hundred milligrams of calcium citrate. This is why you do math in chemistry. Because I have a fraction of a liter, which means I'm getting a fraction of a gram of citrate. And the rest of it is just in my pile of sadness, which is all the filters and stuff. Can I come up with a better way on the fly? A better way to separate calcium carbonate from calcium citrate? If I could add sodium hydroxide, that would work. Is this the stuff that's making the frogs gay? Oh my gosh, you're right. I think you've uncovered the conspiracy. You can get it from Meow Wolf. I can put the link there. Here. Meow Wolf. You can also just look up Meow Wolf gender fluid. They ran like the Omega Mart thing. If you know about Omega Mart, it was like a real life ARG type thing. But yeah, I can put the not an affiliate link. Here's your not an affiliate link. I will get an affiliate commission of $0 if you buy it from there. There we go. It's going. It's close. It's so close. We're so close. We're so close. See, this one's just like wet. This is wet. It's not even filtering anymore. It's just wet. Amazing. Perfect. So I guess we can start with this one. And it's time for a switcheroo reaction. So we have hopefully calcium citrate, if not very much of it, and sodium carbonate. We'll switch around to get calcium carbonate, which is insoluble and should precipitate, and sodium citrate, which we can use to make smooth cheese. Why was I okay doing this as a stream? Why are my standards this low? Alright. Pure baking soda. Is this actually food safe? I just saw baking soda. I never saw if it's actually food safe. Cooking and baking. There we go. See, look. Uses, random stuff, pet, DIY lab and play, and cooking and baking. We're like here. We're like at this point in the circle. We're in between cooking and baking and DIY lab and play. It's perfect. Alright, let's see if anything precipitates, because I'm kind of hoping it will. We'll get some citrate and some melody and stuff. But I think we just have to kind of full send. That's a lot. Okay. Sodium carbonate is insoluble in water. Is soluble in water. Very soluble in water. So we should be able to put lots of it in here without a problem. And that can ensure our reaction goes to completion. And what comes of this? We have precipitation. Oh my gosh, we do. Hell yeah. Okay, so there was some kind of something in there. We don't really know if it's citrate. If it's citrate ions or other ions. But it's probably like a mix of citrate and whatever other ions are in lavender and lemon. That is a very, very cloudy solution, which makes me think this actually maybe works. But it could also just be stuff that hasn't dissolved yet, so let's give it the old go around. Because although stuff like calcium hydroxide and calcium citrate are like close to insoluble in water, they're very, very slightly soluble in water, calcium carbonate is like 100 times less soluble. Oh, Poisson! Hi, Poisson! When you do any chemistry, do you have to fight the urge to taste test random chemicals? It depends, because there are some chemicals, like potassium dichromate is an incredibly carcinogenic chromium compound, but it looks like the most like delicious like orange carrot. It looks like pure Cheeto puff. I don't know. I don't really know how to describe it, but it's potassium dichromate. It looks so good, but it's so toxic. This is why I get to do this, because I can just be like, oh, hey, what's up with this solution here? Does this contain citric acid? Let's just taste it and find out. Let's actually do this. Does this have, okay, what does this have? This shouldn't have any sodium hydroxide. Yeah, that's fine. Oh, I should not have done that. That tastes horrible. What was in okay, so what chemicals did I just drink? Calcium citrate, water. I mean, it does taste kind of citrate-y. Citrate-y. That's promising. That's promising. Oh, it tastes so bad though. But I guess that's good, because if it tasted good, that would mean we just ended up with our starting material. Our starting material tastes good. If it doesn't taste good, that means we did some chemistry, I guess. We've extracted the citrate and probably malleate ions from our gender fluid, and now we can do stuff with them. I guess I can just compare, just for comparison. Taste everything. It's so crazy that they actually did that, though. They actually did just taste random stuff. This is good. What chemicals did I just drink? Safest chemistry VTuber. Yeah, it's Look, I knew they were all probably food safe and probably not caustic. Although this stuff is actually kind of caustic, but not really. It's not caustic in comparison to calcium oxide or anything, or sodium hydroxide. This is why I have to be careful. I do kind of want to be careful about this, because if I have excess calcium hydroxide get into the reaction with this, then what happens is it probably will form sodium hydroxide, I think. Will it? It'll form at least some. It'll form at least some sodium hydroxide, which is used in cooking for pretzels and stuff. If you're over in the southwest of Germany, they have their pretzels made with lye. Sodium hydroxide is the same as lye. Then, yeah, you it is used in food, and this would probably be food grade, but it's also sodium hydroxide, and I really don't want to consume an unknown amount of sodium hydroxide. Let's see if we can filter this though. There's even the layer stuff at the bottom. This seems like it might actually be working. Holy shit. Holy shit. Filtering time. All of this is filtering and filtering. This this is actually not what inorganic chemistry is like. Inorganic chemistry is not just filtering and filtering. Um, but when the only food safe equipment you can buy is a cheap pack of coffee filters and cups, you're just gonna end up filtering all day. Oh, like how lead was used in paint, so definitely safe. Yeah, exactly. That's why I actually, for a future project that is kind of dangerous, I'm not using lead. Where was it? Where's my bismuth? Do I want to touch the bismuth? Yeah, it'll be fine. It'll be fine. It'll be fine. Bismuth is non-toxic, right? I was showing this off in the beginning of the stream, but I'm presuming you weren't there. I have some bismuth now. Here's my glorious chunk of bismuth. It has all the pretty colors on the surface and all the shiny on the side. I have a pound of bismuth now that I can use for a future undisclosed project that may or may not involve radiation in some way. But the thing is, I'm not sure a pound of bismuth is enough. I kind of might need like 3 times more than that, which would be really expensive. So I don't know. I think I can use stainless steel for some of it. I can use a mix of like stainless steel and bismuth. That's my kind of current plan. But yeah, shiny rock. Exactly. It's a lovely, lovely shiny rock. Okay. I did kind of get bismuth all over my hands though, so I guess I can wash them out. There we go. Amazing. Perfect. Now I have bismuth water all over my table. The other thing is because bismuth's atomic symbol is bi, or like Bi, I kind of want to be like the sequel to this stream can be doing some stuff with bismuth, and then instead of gender fluid chemistry, it can be biochemistry. I just think that would be funny. Also, bismuth chemistry is weird and cool. It's hard to do, and I probably would need to start I couldn't start with the pure bismuth because the only thing that like dissolves pure bismuth is nitric acid that's really concentrated, and I don't have concentrated nitric acid, and I kind of don't want to make it in a dorm room. So I'll probably have to. I'm thinking I can maybe use like Pepto-Bismol pills though. Crush them up, extract the bismuth subsacylate. I think that could maybe work. And then we could do biochemistry. Okay, why isn't this filter thing? There we go. Why isn't the filter filtering? Okay. You over here. An entire gay chemistry. I know, right? It'd be perfect. It'd be so good. All right, let's see if I can filter this. On the one hand, the fact that there's not very much precipitate is good, because the precipitate is like, we're discarding. It's just calcium carbonate, we want to get rid of it. But on the other hand, because of the way the chemistry works, there's going to be as much precipitate as there is product. So the fact that there's not very much precipitate means we did not make that much citrate. We did not make that much sodium citrate. But there's some, right? You can see there's a bunch left in the bottom there. I wonder if I should have put this across 2 cups. It'll be fine. Obviously, streaming chat. I guess now. I was gonna say Twitch chat, and then I was like, wait, no, it's YouTube. And then I was like, wait, no, I have both. And then I was like, wait, no, Twitch stopped working. Actually, Twitch never really worked in the first place. I'll figure it out later. But yeah, I would. YouTube chat is infamously known for having unending amounts of patience. So surely I can just put it in 1 cup and just wait. Talk about stuff. I don't know. We're trying to make cheese soft. Actually, earlier this morning I saw a cool article about cheese, where apparently in Denmark, yay, shout out Denmark, they found on an archaeology site, they found a pot of cheese that was like, it was a pot of burnt cheese. Where as far as the like, I don't know, I guess you can't say for sure, right? But like the leading theory is that someone was trying to make cheese, they failed miserably. And so they just threw away a pot with a bunch of burnt cheese in it. It's great. Yay, Denmark. I don't know, that's a cheese story. Is it filtered yet? No. Darn. I guess I can add a little bit more water there. Help it go through. Come on. Okay, any other cheese or sodium citrate related stories? I don't know. What else? I mean, cheese is good. Why am I so bad at this? I like cheese. Why can't I think of random cheese facts? Um, you know Gloucester. There's the cheese called Gloucester. It's an English cheese. There's a tube stop on the London Underground called Gloucester Road, and I always like Gloucester cheese. It always makes me happy because whenever we would go to like central London, well, not whenever, obviously, there's more than one tube stop in central London, but like whenever we go to the museums or stuff in central London, we would always get off at Gloucester Road because there's Gloucester Road and then there's High Street Kensington, and High Street Kensington is like closer to the museums and stuff, but it's always super busy and full of tourists. So when we were like, you know, living in the UK, it was always go to Gloucester Road and then just walk a little bit. It's not even like it's a nice area to walk around. So that was the Gloucester Road Gloucester always makes me think of London because of Gloucester Road and the tube stop. So there's your I don't know tube tips. I haven't been to London in a while though. I didn't go this summer or anything, but a friend of mine did, and it was their first time out of the country, so that was kind of cool. My computer's so hot. There's like some of something. I don't know if it's gender fluid or any of the solutions I've been making spilled on like my computer a little bit, but it's like the water's like evaporated away because it's so hot. I even turned off the Twitch thing. Okay, well, we'll figure it out. What I'm hoping to do in terms of restreaming is I'm hoping to, in terms of, why is my model being screwy? There we go. In terms of multi-streaming, I'm hoping that I can basically use, like I have a VPS, and so I'm hoping I can stream, like send one stream to the VPS, and then the VPS can send streams both to Twitch and to YouTube. It might add a little bit of latency, and I don't have the greatest VPS in the world, but, it should be better. Your computer will use the. I mean, technically you're right. Technically you're right. Oh man, you're giving me like video ideas or stream ideas or something now. Because there's definitely more stuff I can do with this gender fluid. That would be very funny. I don't know if I can cool a computer with it. I'm not Linus Tech Tips, and also I don't have a computer. I mean, I have a laptop, but like, maybe there's a way to do it. Maybe there's a way to do it. I can use it to cool something. I'm sure I can use it to cool as a coolant for something. I've never done like water cooling or something before, but it could be fun. Well, the carbonation. The thing about carbonation is you generally can't pump carbonation because the bubbles just like mess with most pumps. A peristaltic. What is it's a stupid word. Peristaltic. Is it peristaltic or peristaltic? There's a kind of pump where it's really stupid. Like it literally is just like a tube, and then it just like squishes the tube to like force liquid through it. I think it's peristaltic. Those kind of pumps I'm pretty sure can pump carbonated fluid, but the your average like ordinary impeller pumps where it's just like blades, those generally can't because it just like makes a big bubble of gas where the blades are. And so I would either have to get rid of the carbonate, like get rid of the carbonation, which I guess I could do, but then it feels I'm not using gender fluid. I guess I'm still using gender fluid. That would probably still count. Or I'd have to use a peristaltic pump, which those are really slow because it's literally just like squishing a tube to push the liquid along. I assume it works like magic. Yeah, honestly, that's my water cooling knowledge. That's about the extent of my water cooling knowledge too. But I don't know, it'd be fun to do. Like it's cool. Water cooling's cool. Let's see if this is phone filtering. Oh, it's so close. It's so close. Oh, it's actually is like fun filtering. There's stuff there. We did some reactions. Calcium carbonate. We had calcium ions. We extracted stuff. Yay! There's calcium hydroxide that would also make this, but there wasn't much calcium hydroxide because it didn't react before. This is what chemistry is like. Yay! Okay, there we go. You can see that. Here, I'll hold it up so you can see it. There's more white precipitate. That's our calcium hydroxide. Peristaltic pumping is the same way food gets swallowed. Yeah, I think that's right. I don't know how food gets swallowed honestly, but I believe it, right? Because it's just like literally just like there's a point where you squish the tube and you push that point down, and then you 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 you. It makes all peristaltic pumps make that sound, including the one in your stomach. It's just really quiet. You can't usually hear it. Come on, there we go. So this should have sodium citrate. I guess I can taste it again and see if it still. I guess I can taste it again and see if it still tastes citrusy. I don't know how much we're gonna be able to get as a solid, but I don't know if we actually need it as a solid. I don't know if we actually need it as a solid. And then we have to do the part. Then we have to do the cooking part of this, which is melting cheese, probably in a microwave, because there's an oven, but I don't have a pot for it, because I thought I could use the kettle, but I couldn't find the kettle. Hell yeah, swallowing stream. Yeah, yeah. That's the next stream. I'm gonna get one of those like cameras that they go in to like see your throat. There'll be a stream all about swallowing. I'm not gonna do that. That sounds horrible. I guess I can drink some more gender fluid in the way. Delicious, delicious. It is actually pretty good. It kind of reminds me a bit of if you've ever been to like Germany, or I think it's pretty common in the DACH region, right? So Germany, Austria, and Switzerland. Although I don't know if I've only been to Switzerland for like 20 minutes to change trains, so I have no idea if it's in Switzerland. But it's definitely a thing in Germany, and I'm pretty sure it's a thing in Austria. I was in Vienna for a bit, where they have this thing called Schille, where it's like my voice, my voice. I guess I could drink some water. I've been drinking gender fluid and random chemicals. So pure, so pure. There's no citrate ions in here. There we go. The oh yeah, Schille. It's basically just like a mix of juice and sparkling water, and it's really good. And you can get like Apfelschelle or something like basically anywhere. This kind of reminds me like the taste of that. It kind of reminds me of Schille, which is a good thing because Schille is delicious. The more Schille in the world, the better. All right, let's. There we go. It's basically done. Yeah. So there's our calcium carbonate product. This is still it's not a me. It's okay. I think it's okay. Why is it cold? How did this get cold? Is the dissolution of one of these things endothermic? Why is it so cold? It's actually like a really hot day outside. This is kind of nice. Is it the reaction is I guess it makes sense for the reaction to be endothermic. I think that actually kind of makes sense. I don't know which exact reaction is which, and I'm too lazy to look it up. But I think it's the reaction, not the dissolution, that's endothermic. Because my very limited knowledge of like enthalpy and stuff, that makes sense. That would make sense. I guess we can taste it now. Give it the old taste test. This is hopefully our like final product for I don't know the chemistry side of things. Some delicious sodium citrate. Here you go. Here goes nothing. No, this is so weird. Wait, this is so weird. It definitely tastes different from the calcium one. It kind of tastes like there's still baking soda in it, which makes a lot of sense because I dumped a bunch of baking soda in it. The only way to get rid of that is either to, It definitely still tastes citrusy, but there's definitely some baking soda in it. I love that I'm just like replacing the entire field of analytical chemistry with just eating it. This is so great. I could cool it down in the freezer, but there's still probably not that much will crystallize out. I could boil it, but that would be probably lose a bunch of the product. What are we gonna do? What's this one too? This is why you keep track of your things. I think this is calcium citrate, and this is sodium citrate. I think we only processed one of them. Let's taste to be sure. Yeah, okay. This is calcium citrate. So I guess what we can do is try to react less of it because we don't want to have an excess. We don't want there to. Does that make sense? We don't want to put too much baking soda in because the excess baking soda will just stay dissolved, and we don't really have a good way to separate it. We want to react exactly as much baking soda as we need. And if there's a bit of extra calcium citrate rather than sodium citrate, that should be fine. But extra baking soda will taste like baking soda. So what I think we want to do is make a stock solution. We'll dissolve some baking soda, and then we'll basically just pour it in until it stops reacting. So let's... How are we going to do this? Yeah, okay. So this is our one that's mixed with baking soda. We'll put that over there, right next to the old book that's out of frame. Is that a library? Oh, that is a library book. Okay. We'll save a little bit of this so that if we go too far, we'll have some left over. There we go. I'll try to remember. Normally, the actual lesson, label your chemicals. I'm not doing that because they're all edible. It should be fine. It'd be fine. Everything's fine. Everything's fine. Okay. We have our essence. We have this. Now we make solution of. Am I out of water? Shit, I have to go get water. Okay, I will be back in like 10 seconds to go get water. Literally 10 seconds. Where's the text? How do I do OBS? Yes. Text. Be getting water. Give me like 10 Sekunden. Dankeschön. There we go. Perfect. All right, I will be back in a very short amount of time to go get water. By the way, if you're wondering what the OE thing is, normally that's the O with the two dots on top, but I don't have a German keyboard and I'm too lazy to Google O with two dots on top and copy it. So you get the ASCII version. I will go grab water. All right, I'm back. See, that was pretty fast. I feel like that was pretty fast. Well, they're gone. Let's do dangerous chemistry. Oh no! Does anyone know how to do it Walter White? I mean, this is the thing, right? It's like meth is really easy to make. That's why it's such like a problem or whatever. It's like one reaction you have to do. It's really easy to make math. Yeah, chemistry with the bathroom cleaning supplies. Well, that's the thing is it's obviously like I'm limited doing stuff with food safe whatever for this stream, but if you limit yourself to like what's in the hardware store, you can do so much. You can do so much Home Depot chemistry. It's just the limits to what I do when I'm doing chemistry with stuff from the hardware store. The limits are not what I can do with stuff from the hardware store. The limit is what I can do. I can't read this. The limit is what I can do safely. Right? Taking notes. I mean, I guess there's going to be a VOD of this, so I can't say like don't record it because I'm recording it. I guess take your notes. Take your notes. How do I make rocket fuel? I mean, rocket fuel is just like a fuel and an oxidizer. So there's a bajillion different kinds of rocket fuel. The better the rocket fuel is, the more terrifying it is in terms of safety. But like, actually, in a future stream, hopefully the stuff for it I just got off Amazon are coming Tuesday. There's a kind of chemical called chlorates. So like chloride there's kind of like a progression where you start with chloride, it's just a chlorine atom. Then you take add an oxygen atom, so you have a chlorine and an oxygen atom. That's called a hypochlorite, and that's like bleach is like typical bleach is sodium hypochlorite. So you have hypochlorite, and then if you oxidize that even further, you jam even more oxygen in it, you get ClO3, which is a chlorine and 3 oxygens. That's the chlorate ion. And because there's so many oxygens jammed in there, it's used for a lot of like amateur like pyrotechnic compositions. I think it's used for some rocket fuel stuff. It's not that great at rocket fuel, but chlorates are used for that kind of stuff. And I want to try making some weird chlorates. The typical way you make like it's not that hard to make sodium chlorate. You can make sodium chlorate from sodium hypochlorite, which is bleach. Then when you extract it, the thing most people end up with is sodium chlorate is I can't talk. The thing most people end up with, like the final product, is people mostly make potassium chlorate. You start by making sodium chlorate from bleach, but it's mixed with a bunch of other stuff. Potassium chlorate is like less soluble in water or whatever, so you can extract the chlorate from all the other junk fairly easily. I want to make weird chlorates. Normally, the way you make weird chlorates is you have to use either barium, which is super toxic, or silver, which is photosensitive and annoying. And I think I found a way to do it with iron, so I want to try. But there's like no information on iron chlorates like anywhere, so I want to try doing that. I want to try using iron chlorate to make some weird goofy chlorates. So how do I make rocket fuel? I may or may not be telling you in a future stream. Use this information responsibly. Okay. What were we doing? Oh right, I needed more water to make baking soda solution. I guess I can use the paper cups now. We'll be environmentally friendly and use the paper cups. All I'm doing is just baking soda. There we go. So we can dissolve a bit of this. There we go. We want to make a saturated solution ideally, but I don't want to actually go through the effort of making a truly saturated solution by filtering it off, because filtering takes time, and I'm impatient. So we'll just kind of guesstimate. There we go. Delicious sodium carbonate. Wait, this is sodium bicarbonate. Delicious sodium bicarbonate. It's close enough to sodium carbonate. They're mostly interchangeable. Although there's certain weird cases where like the carbonate ion can't exist in water, but the bicarbonate ion can, or vice versa. I think it's the opposite is what magnesium is like. Like magnesium bicarbonate doesn't exist, but magnesium carbonate does, or maybe it's the other way around. I don't remember. I haven't done magnesium stuff in a while. There we go. That should dissolve enough. I guess I can add a little bit more to make sure. Doot. Sploosh. Sploosh. Okay. So now we have our... That's too much water. Why did I put that much water in there? The sodium carbonate can dissolve very easily. This bad... It's like the slapback of carmine, right? This bad boy can fit so much sodium bicarbonate. I think the bicarbonate is more soluble than the carbonate. One of those is more solid than the other. It's weird. The carbonate bicarbonate thing is weird because they're basically the same ion and they can like interconvert and stuff, but they have like different solubilities and sometimes one of them is stable in water but the other one isn't. It's weird. It's whack. Okay, yeah, sure. So now we take this guy. We want to add just small additions. So we only want to add as much as actually reacts. Oh, look at that. It's all cloudy. A little bit more here, see if it reacts. See if it reacts further. I think it reacts further. I can set this down and wait for it to separate. At least a little bit. I don't really care for it to separate like completely. We'll filter it off at the end. But I want it to separate enough where I can actually see if my additions are doing anything. Again, the proper glassware to do this would be like you have your addition funnel and your little beaker at the bottom and you drip, do it dropwise. No, we're not doing that. Rocket fuel, other rocket fuel. I mean, basically anything that's like any chemical that's terrifying and is a fuel and an oxidizer. It'd make rocket fuel. I should say potassium chloride is just an oxidizer, right? You still need the fuel, and what matters, the fuel matters. You can use sugar as a fuel, but it's not very good. That's why like potassium. I think it's potassium chlorate mixed with sugar is what people call rocket candy, which is a fun name. But yeah, it's basically like you just need a fuel and oxidizer, and chlorate's a good enough fuel to use sugar, but it doesn't work that well. It doesn't really work well enough for like most rocket stuff. You can use hexamine. Hexamine's a better fuel, but it's not that. I don't think hexamine's that hard to obtain. I've never tried to obtain. Yeah, exactly. Anything is chemistry equipment if you improvise enough, and that's one of the stupid things. Like there's some state. I remember reading this where they have a law like they don't want people making their own medicine, which is a complex thing because like do you want people making a bunch of like crappy medicine to sell? No. Do you want people to not be able to do like anything on that front just in their garage? I don't think you want that either. But anyway, so the state doesn't want people making like their own medicine, and so they said you're not allowed to possess a pill press, where a pill press is literally just like a thing to press powder into the shape of a pill. And it's like, well, a pill press is just anything to press a thing with. Right? Like your fingers, you can press powder into the shape of a pill. Like it's so dumb. I don't know if it's still a thing, and I'm again like I don't really know much about this. This vague recollection of something, but yeah, anything is chemistry equipment if you improvise enough, which is great for doing amateur chemistry in terms of being able to do it. But sometimes there's dumb laws, and you're like, wait a minute, like what do you mean? Anything you can do that with anything. You can do that with anything. Like another really stupid one is like in the U.S. There's certain things that are like plutonium or uranium 233 or whatever are classed as special nuclear material, and because of that, you're not allowed to have like a single atom of them. It goes all the way down to zero. It doesn't make any sense. The law makes me so mad. I'm so pill-pressed. All is good. Yeah, it's so dumb. I think it was like Arizona or something. And again, I don't know if it's a real thing or if it's just a bill or whatever. It's still dumb. Whatever it was dumb. But the thing with like special nuclear material is they have the law that goes down to they have this law that goes into zero. It just doesn't make any sense. Like, yes, okay, I'm sure you don't want people. You obviously don't want people to have like grams of plutonium, but the law is, as the law is written, a single atom of plutonium is illegal to possess. Which, like, if you know anything about this, like stuff changes all the time, right? It's technically possible for a cosmic ray, a gamma ray from space, for a cosmic ray to just randomly hit the americium in your smoke detector, and if it has high enough energy, there's a cross section there that can do a spallation, and then you get I don't know if it goes directly into plutonium. I think it does go directly into plutonium. Then you beat plutonium, and technically, you're in possession of a probably one or two atoms over the course of a couple of years, maybe decades. I haven't done the exact math, but like, you can't just have laws that go down to zero like that. It's so dumb. So many dumb laws. Okay, let's see if this is. What were we waiting for again? Oh yeah, we were waiting for this to separate. I'm very, very on track and know what I'm doing. So we got our sodium bicarbonate. Let's see if this does any more. If we add more additions. I'm not sure it is. I don't know. It's going a little bit. It's going a little bit. Like, a little bit more. Yeah, I think that's it. I think we've kind of hit the limit. Well, then maybe a tiny dash more. So we don't have that much citrate. I kind of want to get everything we have. But then I can put the rest of this in now. So we'll wait for this to settle for just a couple of seconds. Doesn't uranium ore, which is basically destroy. Yeah, exactly. This is the other. The thing that's a little bit makes uranium ore a little bit less bad is a lot of these laws have an exemption, or they say different laws cover norm, which is naturally occurring radioactive material. So generally, even if like there's something where you're allowed to, like, you're not allowed to take uranium, like that's like refined uranium over there, you're often allowed to do things with uranium minerals that you aren't uranium minerals or uranium ore, which are kind of the same thing, that you're not allowed to do with just like pure uranium or sometimes even depleted uranium. The regulations around this stuff get super weird, and I don't want to give away too much, but for a thing I have been planning and working on, it may or may not involve those regulations. Where's my hair getting in the way of the camera? There we go. So, yes, it's very dumb. Yes, uranium ore can sometimes contain trace amounts of plutonium. Let's see if this reacts. But I think that might be covered under the exception for naturally occurring radioactive material. If that exception exists. I don't really remember because I don't have to deal with that. Okay. We can stir this up a little bit. We shouldn't really need to, but it's good. No problem with it. Nothing wrong with like stirring it too much. There we go. There we go. And you probably can see it. Is there a layer at the bottom this time? I think I might have just turned it off. This is weird. Goofy, I say, goofy. All right. So we've get this going. Oh yeah, it's going. It's just I stirred it up, I think. I guess I can get another cup. So many cups. This does seem like it's actually vaguely working though. Like even the one over there that was contaminated with a bunch of calcium citrate, or that was contaminated with a bunch of baking soda, still tasted citrusy. I'm gonna drink some water. I was watching Mylan, which if you haven't subscribed to watch Mylan Akamon, the psychology science VTuber. Yeah. But he's like a Twitch bits, whatever it's called, shiny objects redeem thing, where you could call for a hydration break. I need that. I need to do that. I have not been drinking enough water. It's not really separating like it did before. I wonder if there's just less of it. Because if you have a very dilute solution, it's not gonna separate. All right. Filtering time for the 40,000th time today. So much filtering. this one a little bit more. We'll see. Oh, oh yeah, there we go. Now you can kind of see the milky stuff. So it did kind of separate to the bottom. It just didn't go all the way to the bottom, or it didn't go enough to form powder. How does milk powder work? That's a very good question. I don't know the details of how milk powder works because the thing is, I think it actually might be kind of similar to what we're trying to do today with the making cheese smooth, because milk has a bunch of like fats and stuff, and for it to dissolve in water, you need it to interact with the water, and like fats and stuff are hydrophobic. They're not going to want to interact with the water. So, I think I wonder if it has something to do with like emulsifier. I'm sure there's some kind of emulsifier in it. I don't know if that's the exact detail on how it works. Like if there's something else that does the bulk of the milk powderifying. It's not just like milk stuff in an emulsifier. But what we're trying to make, sodium citrate, which is hopefully going to the bottom of here, is the reason we want it is it's an emulsifier. So an emulsion is when you have a bunch of insoluble particles that are suspended in a soluble. When you have a bunch of particles suspended in a medium in which they are insoluble. So like in something like milk, what you have is like particles of fat and stuff, which are not soluble in water, but they're kind of wrapped up. The emulsifier allows them to interact with water by means of the emulsifier, and then they can dissolve in there. This is kind of an oversimplification, but that's the general idea behind emulsifiers. Sodium citrate is an emulsifier, and I think milk powder probably works by a similar way, since milk is mostly like fats and oils and stuff that isn't soluble in water, but and an emulsifier can make that work anyway. But I'm not sure. I don't know the exact details. I do kind of wonder. I've always kind of wondered about the like if you ever go to France, they have the milk that like you don't need to put in a refrigerator. I think Belgium too. Um, for some reason, it's not that common in other places, but like it's kind of convenient and nice. It just tastes a little. It tastes a little bit weird, but it's nice. So yeah, I've always kind of been curious about that too. So maybe I'll have to look into more milk science. All right, I think this is going now. It's a good question though. Oh yeah. Oh yeah, that's going. That's going all right. Was that everything? Oh, it's over here. I was like, where did it go? Where did all my stuff go? There we go. Yeah. I guess it could contain some. I'm trying to be careful to get even the insoluble particles to filter through because there's a chance that the like insoluble calcium carbonate. Yeah, the insoluble calcium carbonate can trap some of the citrate. Sometimes there's even weird interactions too, where they like complex or interact with each other, and then you can have it actually like, even though you have a tiny amount of citrate in the whole thing, most of it is gonna stick to the calcium carbonate or something like that for whatever reason. So it's generally a good idea to get all that you can out of here. So I'll just pour in a little water and we'll try to filter this all through. Do it once more. There we go. Just to be safe, yeah. We really do not have that much calcium citrate or sodium citrate here. We probably have like not 100 milligrams, hundreds of milligrams. I think that's probably a fair thing to say. Is this going? Oh yeah, it's going. Yeah, going. So then we'll taste it to make sure it actually tastes like sodium citrate, even though I've never tasted pure sodium citrate before. And then I guess I can go try to microwave some cheese, and we'll see if the melted cheese makes it more stringy. Because this is the thing; it's like this is basically how like American cheese works in a similar way. And fondue doesn't actually use stuff like sodium citrate. It's way older than before we figured this stuff out. Like the wine is what does the wine when you're making fondue and stuff. The wine is what actually makes it possible for it to stay as like an emulsion and not just like degrade over time and stuff, and be all like fondue. But when we're using an emulsifier, that's how you get the smooth sort of cheese, like American cheese. The where it's like all kind of floppy and stuff. It's not. Not then it has to be called like pasteurized cheese product or whatever because it's just like the offcuts of other cheeses mixed with an emulsifier, which is often sodium citrate. So we're basically making American cheese, which is also mac and cheese, which is also it's just cheese that's smooth instead of stringy. That's the plan. Oh, actually, I should shout out who in the Discord gave me that idea. But I want to. I think it was Stumpy Bumpo, who's not here right now. But I want to check because I was like gonna do something with this. I was gonna make citrate salts. I was originally gonna make potassium citrate, I think, because it's a I don't know, it's a fire retardant. Potassium citrate does some interesting things, but this is more fun than that. So where was it? Was it in channel ideas or science? Where did it go? I thought I had it. I thought I had it somewhere in this Discord thingy. Where, whatever happened to it? Okay, well, I think it was Stumpy Bumpo, but for some reason I can't navigate through my own Discord to figure it out. So amazing, amazing. Anyway, this should have filtered by now. There we go. There's our residual calcium carbonate. So again, we did not make that much if that's how much calcium carbonate is in there. I mean, technically it's like 2 times as much or whatever because calcium carbonate is like calcium. The calcium ion is like a charge of 2 plus. In if you have the carbonate ion, calcium carbonate, calcium is 2 plus, carbonate is 2 minus. You have like it's a 1-to-1 ratio. Sodium is 1 plus, so sodium carbonate has more carbonates than calcium. I'm not explaining this at all. It's moles. It's moles. If you ever did moles, if I have a single each, the sodium connects to the 2 carbonates, except it's actually bicarbonate. So what I said wasn't really true. And now I just got I squeezed the box and I got baking soda on my computer screen. That's all right. Anyway, this here hopefully is our sodium citrate. We can actually give it a taste test now. Finally, a true taste test. Let's see. It still kind of tastes like baking soda, but it's a lot better, and it's a lot less strong than the calcium citrate was, which makes me think we have like a huge loss. It's weird. I guess I could taste baking soda water to compare to make sure this isn't just baking soda. I'm kind of worried it's like complex with the calcium carbonate or something now. Where's my baking soda water? I hate that. I'll dilute the baking soda water so it tastes less horrible, but I guess let's see. Let's see what baking soda water tastes like. Ah. Ah. Ah, that's poor. Okay, well, it's definitely not that. Why did I do that? Don't drink baking soda water, kids. It's horrible. I thought the other thing tasted bad. I was like, oh no, it tastes like bad tasting baking soda water. I had no idea how bad baking soda water actually tastes. Oh my god, this is awful. It's the... I'm dying. Save me. It's so bad. If my mouth still tastes. Okay, I drank some clear normal water to try and dilute it or whatever, get rid of it. Holy shit. Oh, that was awful. I cannot express in words. The English language is not enough to express how horrible that tasted. Oh my god, that was so bad. Wait, don't stop it, might be an acquired taste. No. No. Oh. Oh my gosh. Why? Well, with my amazing feat of analytical chemistry, I can conclude it's definitely not just baking soda water because holy shit, that was awful. I still taste it. I need more regular water. It's so bad. Why did I do that? It was for science. I know it was for science, but that was horrible. That was deeply horrible. Well, well, maybe some gender fluid will help clean my taste buds from this. Some of the glorious gender fluid. Let's see if this helps. Oh, that's so much better. It's so much better than. I mean, given I'm paying $5 for it, I would hope it would taste better than baking soda and water. But like, oh my gosh. Well, what we have here is probably sodium citrate, probably. Oh my gosh. I guess I have to go down and melt some cheese now, which is down 4 floors. Is it 4 floors? Whatever. Time to melt some cheese, I guess. I only have 1 cup left. Shit. I mean, I guess you could call this good planning, because I have the exact number of cups I need, but like, oh, there's water everywhere. Come on. Okay, this is our. We have to remember this one, this over here, over this way, off camera. That's our calcium citrate, or that's the one that has probably some baking soda in it, but it might also, now that I've tasted baking soda, it might just be more concentrated. Or it might be, whatever, not more concentrated, it might be less bad. It might be less bad. Let's start with this one. We'll start with this one. And we'll see what we get. I think it's too it's too insoluble. Well, yeah. I think we have so little of it that even if we freeze it, we're gonna get like barely even enough for crystallization. Like, we're not gonna be able to extract it that way. We're just gonna have to heat it up with cheese and the water all boils off, and that's the plan. Again, I don't know the amounts at all here. I'm literally just using all of the sodium citrate I have. So let's make a mix of cheese. I found some recipes. I'm not going to look at them. I think that would defy the spirit of this stream. So we're just gonna put amounts of cheese in. We have aged cheddar and Gruyere. The Gruyere says a creamy, nutty flavor. So maybe it's already gonna that's promising, right? Gruyere feels like it could be easily smoothified. Now we have to cut these open, and I don't really have just like scissors. I have a plastic knife. Will the shitty plastic can shitty plastic knife cut through cheese? Or not cut through cheese. I know it can cut through cheese. I want to cut through the wrapping. Yeah. No. Oh, there we go. Wait, shit. Why is this so hard? I mean, the real question is like, why did I decide to do this? But no, why is this so hard? Why don't they make this openable with a plastic knife? Come on. God damn it. Why is it always the stupidest things that end up taking like half the stream? That was a joke. These stupid things take the whole stream. The whole stream is stupid. Oh my gosh. Come on. Why is this so hard to open? What did they do? I just want cheese. I've suffered through so much. I haven't actually suffered through so much. This is still going better than the tofu stream, but... like, come on. I just want the cheese. We're so close. What the fuck? Can I open it with a fork? Can I open it with a fork? Let's see. Yeah. Right, I can just stab it. Oh, there we go. See, it's stabbing. The stabby is stabbing. And then I just gotta go stab it in the right place. I was bending the fork. What the fuck? Why did they put the strongest plastic in this cheese packaging? Why am I so bad at everything? Oh, there we go. The fork is kind of munged up, mangled.
That's not a thing. I don't know why I said that. There we go. There's a hole. A hole is something to work with. A hole is a start. Yeah. And I already broke the fork apart. Okay, yeah, sure. Well, there's going to be some contamination of whatever the fork touched, but it's all food safe. Everything's food safe. It's fine. Everything's fine. Okay. Now we can cut some pieces of cheese to put in our cup here. Yeah. We ideally want small. Fuck. I will have to clean it up after. We ideally want like small pieces so that they'll melt easier. But I mean, it shouldn't matter that much. We'll cut it like this first. There you go. See, I know what I'm doing. Perfect. I don't really know how much to do because it kind of depends on how much emulsifier we have, which, as far as I can tell, is basically none. Or it's not none. It's very close to none. It's not a lot. But I think this, and then we'll have a little bit of here. That'll be good. I think it'll be easier to stringify or it'll be easier to smoothify if we have a balance that's just more towards fruity urban. You'd think I would like have planned ahead or know the answer whether that's true, but I'm just kind of guessing. There we go. We'll cut into pieces. That feels like that's a decent amount right there. That's some cheese. With some cheese, I'll put a little bit more. You can get a few more little nodules, whatever. Bits. A few more bits. That would make more sense if I was actually streaming on Twitch and Twitch didn't not work on me. Okay. Yeah, I'll set it there. That's cheese numero uno. Why is there water everywhere? I mean, I know where there's water everywhere because I've been spilling water everywhere, but like... God damn it, okay. Now for the real challenge. Can I open the Gruyere with the fork that I've already broken off part of? Also, it's all wet. Wow. I wonder if it's just the like condensation in the fridge and stuff. There we go. See, the fork is your friend. Never doubt the fork. The fork is on your side. The fork is an ally. I mean, I guess this is a gender fluid stream, so it doesn't make sense that the fork would be an ally. See, it's perfect. This was all meticulously planned out so I could make that joke. Okay, seriously. Now the fork is being not a good ally, because I can't open, actually, the hole that I made. I can make hole, but I can't open hole. Does that make sense? I can create hole, but I can't make hole bigger. Which, because hole is not enough, I need big hole. Okay. Why is this so difficult? Why is this... Oh, now there's more water spilling everywhere. It's fine. Everything's fine. I'm soaking my... I'm soaking in the holy gender fluid. My knees. Undergoing the sacred ritual. Oh, there we go. I got it. Okay. The fork is now more mangled, but it's fine. Everything's fine. Yeah. 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 There we go. Now we take the Gruyere. Yeah. Perfect. And now we can cut. Oh. So does gender fluid give you the other gender? Or does it dissolve the first gender? I think, I mean, the correct answer is depends on who, because gender fluid doesn't just mean one thing. And for some people, there might be a smaller set of like genders they've asked between. For some people, it might just be kind of all over. I will say that me personally, like, I very rarely feel like completely male, and I pretty rarely feel like completely female. But I almost never feel like completely male. But yeah, so for me, it's more closer to giving you the other gender and dissolve. It's like it kind of dissolves the first one. Maybe it forms a complex with the first one. Get it? Because it's complex. Actually, that didn't really make sense. That wasn't a good joke. Yeah, I think it just gives you the other gender, and the first gender stays in solution. But it depends. All right, let's add some Gruyere in there. think this cheese is kind of supposed to mostly taste like cheddar. I think it's mostly cheddar, but we'll add a bit of Gruyere because I think this is more emulsifiable. That's a good amount. That feels like pretty close to the maximum amount I could possibly expect our tiny amount of sodium citrate to handle. And I can put this back because I took it out of the packaging for no good reason. I'm strong. I hit the mate of the gender fluid. Hey, that actually worked. All right, perfect. So we got some cheese. I guess I can try to break it up into smaller chunks by doing that. Like this. There we go. Perfect. Actually, not perfect. Not even good. But that's okay. That's okay. Now we add our this is so stupid. We add our sodium citrate, and we're just gonna kind of hope the water boils off. That's the plan. So we get it all in there. All right. Now this looks awful. Now we go. I go run downstairs and put it in the microwave. So I guess I need the little text thingy back. BRB microwaving gender fluid derived sodium citrate. Probably. I just kind of tasted it. I did not do. And we'll just say that. What do we want to do? We'll go with Dutch this time. I think that's how you spell it. There we go. Oh wait, I know what I can do. Haha. I can make this. I know OBS. I can make this slightly dimmer. And then if I do that, what? Oh yeah. If I make this slightly dimmer, then it'll look better. I just have to go to color correction and then do brightness down. Wait, no, that's not what I want. Defaults. Yes. Ooh, delete. I'm spending more time on this than half the time to just go microwave it, but there we go. I want to take this one. I want to take the browser source, and I want to go add the filter, and then add the effect filter, which is color correction, which makes it less bright, even though that makes it look weird. Why does that make it look so weird? Contrast. What if I just lower the contrast? There we go. That's what we want, right? Now you can see the text better. Yay! Okay, now I will go microwave it, and I shall report back with the results. I will be back in like 5 minutes. Let me turn off my. There we go. Please don't do any dangerous chemistry while I'm gone. You have more time. I'm trusting you more this time. I'm trusting you, chat. And I almost left without my keys and got locked inside. Amazing. Okay, bye.
back. I have good news and bad news. Let me fix the filter thing. Shit. The bad news is that it kind of splattered everywhere, and I had to clean it up. But the good news is that it... Shit. There we go. It actually kind of looks like smooth mac and cheese type cheese. It's smooth. It's so smooth. So, I guess the only remaining utensil I have is a spoon, so we'll go with that. Let's see. Fun fact, microwave manuals often have instructions specifically for chemistry. I've never looked at a microwave manual. You can do a lot of fun stuff with them. There's the classic one, like with a grape, or... Actually, one of the most fun experiments, microwave experiments I did as a kid in like the science center or whatever, was they put I think it was a bunch of marshmallows in the microwave, and you could, if you took out the plate or whatever so it didn't spin, you could see the hot spots for where like it had cooked more or less, which corresponds to the microwaves. If you looked at the back of the box, it would tell you the frequency of the microwaves. And so if you could measure the wavelength, because you could literally see the waves in the marshmallows, and you looked at the back of the microwave, it would tell you the frequency. You could calculate the speed of light. It was super cool. All right, oh my god, wait. Okay, it's kind of stringy. It's kind of doing not what I hoped it would do. But it's definitely better than normal cheeses. That's just hard to tell. It's hard to tell. I think we're like halfway there. It's definitely like the color. We're getting close, but it's still forming these kind of stringy bits. I don't know if you can see. But we're really getting there. And a lot of it kind of looks like it's just because I didn't mix the Gruyere and the cheddar. Right, so this is kind of like, it's not quite one homogeneous mass, but you can see like Gruyere bits and cheddar bits. So I think it's not perfect, but it's pretty close. It's pretty close. So let's, how do I want to do this? I guess we can use the more sodium citrate that I've got over there. And if I stir it a bunch, I think if I stir it a bunch and I put it back in, that should maybe work. So we've got this guy. I can just taste it again for comparison. It's bad. This definitely does have baking soda in it, though. Oh, look, there's also something precipitating at the bottom. What the heck? Okay, maybe I don't want to use this. I don't really want to reprocess more gender fluid. This is hard to tell, because this is close. Like, I can tell it's close. But it's not quite there. We're so close. Here's what I'll do. I have a plan. I think I put too much Gruyere in relative to the cheddar. So what I'll do is I'll put more cheddar in. I'll add a little bit more sodium citrate. And then we'll go give this another run in the microwave. I'm going to need some more sodium citrate, like regardless, just to dissolve this extra cheddar. But if I add a lot more, or not a lot more, but a decent amount more, I think this should work out. I have faith. I have faith. So we're really close. We're so close. Okay. I actually decided if I want to filter again. Do I have more? There's definitely more gender fluid I could go with. Let's do a rapid fire round. Let's do it. Let's speed run. Let's speed run the extraction of citrate from this. So we'll take our gender fluid, which contains all the stuff. We poured a bunch of it because we need a bunch of it. When we take that, then we add in our calcium hydroxide. And we try not to add too much, because we don't want to have sodium hydroxide and, I don't know, burn our throats or something. This was about what I used the last time. Gosh, there's dust everywhere. It's so fine. Delicious. Delicious dust. Amazing, delicious dust. It'll be fine. It's food safe. It's fine. Then I can... I'll use this fork again, even though it's kind of broken. Let's stir this up.
Give it a bit till it reacts. See if I can get some of the bits that are on the edge there too, because I don't want to. Yeah, we don't want excess calcium hydroxide. Excess calcium hydroxide is bad. A little bit more. And our reactant. It looks like it's not yeah, it's not reacting now. And we filter it. We filter it. This is the speedrun version. Grab this. Grab our filter. Shit. I'll use only one filter and kind of risk it. Normally I use two because you use only one filter. A lot of times you'll break the filter, but I have faith. We're speedrunning. We're doing the speedrun version. We're speedrunning. Okay, yeah. It's good. We don't want our reactants to get buried underneath the precipitate, underneath the insoluble liquids. Alright, we'll start to let that filter through. Well, do another one of these in parallel. That would be faster, but it's not really in the spirit of speedrunning. It's okay. I'll do it anyway. Speed. It's all about speed. It's all about that speed. Yeah, filter. Imagine if these coffee filters weren't like a cent each. What would I do? What would I do in a universe where coffee filters were not absurdly cheap? At least on a per unit basis. Oh, I put 2 or whatever. Throw a little extra there because I think that's mostly calcium hydroxide. Yeah, I think we can. Yeah, right. Those filter out. We'll get ready for the next bit, which is we add sodium carbonate and then we filter it again. I wonder if we can filter directly. That'll make it faster. Are these going? Oh, they're going. They're going. Water to go in there, dilute them. Might as well dilute and wash at the same time. Perfect. Okay, so those should go through. I can set up the so much efficiency. I'll set up the filtering right now. Kind of funny that we wasted the first one. I mean, not wasted, but it's just now filled with baking soda. I can't really use it for the edible parts. Maybe this is good though. It's not a bad thing to like pre-mix the cheese like we have here. So this is already processed and it's not great, not terrible. It's not what we want, but it's really close. But we've like mixed the cheese together, and so it's something. It's something. I believe. All right, here. Okay. Oh, these aren't done yet. They're so close. Come on. You can do it. Oh, that one's really low. 1 second. Nice. And there we go. It slipped a little bit. If it had fell all the way, then we would have lost everything. That would have been bad. Thankfully, it did not. So those are filtering. That should make ourselves some calcium citrate, along with a bunch of other stuff. And we can add it. I'm not sure you actually need sodium citrate for. I think calcium citrate might kind of work as an emulsifier, but it's definitely not as good as sodium citrate. So I think we're gonna go with that. I'm so sweaty. It's so hot. I have left the window open. It's so hot outside. It's probably like 27 or 28 Celsius, which is some number of Fahrenheit. Okay. My model's being wild. Okay. This is almost done. This is also almost done. Cool. Yeah, we can add a little bit more. So the problem is once you get like this layer of particulate at the bottom, then it won't filter through because it's just blocking it. I guess I can try to de-stir this a little bit. Yeah, it's definitely better than like just like if you were to just melt cheese by itself. I think I have done many times. But it's not quite there. We're quite there. We're trying to make smooth cheese. Smooth cheese for my smooth brain that added way too much baking soda and wasted a bunch of our product over here. Okay. Yeah, you're close enough. I guess that's not the end of the world of a little bit of calcium. If calcium carbonate gets in, because like that's just what eggshells and stuff are made of. Like it's not some crazy dangerous thing. It's certainly better than sodium hydroxide. Yeah, I'm just getting junk in there now. Oh shit, I need another. We'll do that one, sure. Exactly. Only those with the smoothest brain can make the smoothest of cheese. That's the plan. Oh shit, this is so. Well, the good thing is the next step we're gonna filter it anyway, and we want the filter it, so it should be okay. This one is go for just a little bit longer though. Yeah, it's okay. I should do what I did before though with the stock solution of baking soda. Can I use the one that I eated? The one that I eated? I'll just pour this in here and then we can make a new one. Wait, shit, I'm out of water now. Maybe I won't do that. Maybe I'll just pour not that much baking soda in. Maybe that's the answer. I guess we'll find out. We've kind of done it 3 ways. In true accordance with the scientific method of only changing one thing at a time, I think we'll try and have all 3 variations of it. Like we'll have too much. We already have too much baking soda added directly. We already have the right amount of baking soda added through a solution. We can try to do the middle one, which is the right amount of baking soda added directly. I think that makes sense. Okay. Oh, come on. Why is this so slow? I know why it's so slow. It's just because there's a bunch of missing fruit there. But come on. Okay. You're good. Yes, get it all over my laptop. Oh, this is so not clear. Okay. Well, that'll be fine. Calcium carbonate shouldn't do anything, right? It should just be a bystander. So that's some baking soda. Some yummy baking soda. Oh shit, I can't really see if it's reacting more or not. Oh, that's not good. I don't have water to dilute it. Okay, well that's actually not great, but I think that's about right. Like I can see it forming a layer of calcium carbonate. Now it's just. Oh shit. Okay. That actually is bad because the way we tell if this is working is just precipitating calcium carbonate. But if the solution is full of calcium carbonate in the first place, I did a crappy job filtering it, then we can't really tell that much. We just have to kind of guess. If you are silly enough, the cheese will be a liquid without any surface tension, and if you spill a millimeter on the ground, your entire apartment floor will be covered with a very thin layer. I mean, is that what happens if you have zero? I guess like that would be like a superfluid, right? Yeah, I guess. I think the thing is the kinetics of it. Like it would take a, it would take in, you would have to have a, you wouldn't just have to have zero surface tension. You would have to have zero surface tension. You would have to have like it takes no energy to move, or like the energy gain from it adsorbing onto the floor would have to be huge. And then it would very, very slowly spread across my entire dorm. Yeah, I guess. I don't think that's possible at room temperature, but you know what? Maybe it is. Maybe it is. Maybe we'll find out. We'll do the research. There we go. It's forming our layer. Oh yeah, it's going. It's a going. I don't know if we're going to add a little water. Can I add a tiny bit more? Let's see if that. Yeah, I think that's enough. Shit. Okay. So now we filter. It is filtering time. And I will try to use one filter so it goes faster. I did not think the stream would be taking this long, but I never correctly guess how long a stream will take, so it's alright. Filter goes Filter goes in. We'll try to keep these separate because one of them I did a crappy job on. That's a decent amount of. It's a pretty decent amount of calcium carbonate, which means we have a pretty decent amount of citrate we're making, or at least citrate plus malleate plus whatever other acids are in lemon juice and whatever other acids which are not insoluble as calcium salts can be found in lemon and lavender. I don't really want to wash this shit out anymore, but that's okay. I don't really kind of doubt that it's all in there. Okay. Filtret número 2. There we go. Come on. Hi, chat. So what I'm making is a little bit very dumb, but I was able to buy this gender fluid drink, and I noticed on the back that it contains citric acid. And so I've been doing some chemistry to turn the citric acid into sodium citrate. And sodium citrate is used for making cheese smooth, in like mac and cheese and stuff. So that's the plan. The plan is to make smooth cheese using a gender fluid. And I made some, and it's a lot smoother than like regular cheese is when you just melt it. But it's not quite like American cheese or mac and cheese smooth. And I also didn't mix it very well, so it's just not that great. So I'm making more calcium citrate, or not calcium citrate. I'm making more sodium citrate in order to do it. In order to hopefully better make some smoother cheese. Smooth cheese for my smooth brain. And so this, let's go. Yeah, I think it's fun. So this, we reacted. What did it? We got calcium citrate. We extracted. We got calcium citrate. We extracted from the citric acid. Then we reacted that with baking soda, so we should have sodium citrate and calcium carbonate, we should be able to filter out the calcium carbonate and be left with just sodium citrate. And we'll try not to get this desk even more wet than it already is. This feels kind of Nile red. I mean, the thing that makes the thing that makes it I feel like the most Nile red is the fact that I get to eat it at the end. It is definitely that like genre, right? Of like, here's some random thing, let's turn it into something different and eat it. Gotta eat it. Oh yeah, that's going. The problem is this process is horribly inefficient because calcium citrate is actually not very soluble in water. So there's only a tiny amount of it that actually stays in solution as we're doing this. But, you know, this is the only way I can think of doing it with chemicals that I can just buy as food safe. So this is the plan. Our evil plan. Oh yeah, it's gone. So that's should be filtering through in just a second. There we go. Sometimes you can let it squeeze it, but it's kind of sketchy. Sometimes the other stuff goes over. Yeah, that didn't do a very good job. It's still kind of cloudy. I mean, it's not that cloudy. But do I like filter it again? I guess I could filter it again. Why wasn't it cloudy last time? Why is chemistry? I'm running out of plastic cups too. I have like 4 more. Sorry, turtles, but I really want that smooth cheese. Yeah, I'll filter this again. I guess I wonder if it's because I'm only using 1 filter in a row instead of 2. Like, I don't really think that would affect it that much, but I guess it makes sense. These aren't, lab grade filters or whatever. This is literally like 1 cent per unit. The unit cost of 1 cent, like coffee filters. From it wasn't. I didn't even go to like a normal grocery store too. I went to this like random giant grocery store in the middle of the suburbs because I needed calcium hydroxide, which they sell as pickling lime, and like it's a kind of a weird thing. But the nearest store I could find it was in the middle of nowhere in the suburbs. So I was like wandering. I took the bus, and then of course the U.S. right. I have to go wander around to the middle of the suburbs for like walk 20 minutes to get to the parking lot, and then walk another 10 minutes. Spend another 10 minutes walking across the parking lot to get to the actual grocery store. Is this clearer? Oh yes. It's not that much clearer. How is it getting through? How is it defeating my amazing filter? How is it defeating me? And why did it defeat me before? Why is this only now happening? I mean, I guess it wasn't perfectly clear It's not bad. It's not bad. This one I think is basically done now. Oh gosh, shit. The technique of it's still not clear. How the hell? What is in this thing that's making it not clear? Is it really just calcium carbonate? Because it's pretty insoluble. It's like 0.001 grams per liter or something. I guess I can eat it. This is how we've been doing all of our analytic. You can see the insoluble. Oh, I think I figured it out. I think it's just still reacting. I think we just didn't wait for it to finish reacting. Because this has been the speedrun version. The first time we were slow and lazy. And that was actually good. Because, well, I was just talking to chat or whatever. It was just, I was giving it time to react. I guess that makes sense. Because we're taking two soluble things and making an insoluble thing. And we just, the soluble stuff will filter through and then it'll just finish reacting after it's filtered. So this filtering has done very little and I'm just an idiot. I guess that tracks. I am an idiot, but like... So this is what a reaction channel is. I've actually been meaning to. Like when I was, like last year, or not last year, this year, the most recent April Fools, I did the Hawk Tuah stream, because there's a chemical called holmium dicarbide, where it's like super obscure chemical. There's like two references to it in like papers from the 1970s. But I figured I could make it in this like microwave furnace that I had with this microwave that I used to have, that I got also from the suburb, but this time from some like random sketchy guy on ripoff Facebook Marketplace. And I was gonna make holmium dicarbide just because the formula is like HOC2, right? So it's like Hawk 2 and then Hawk Tuah. But the original April Fools, like when I was trying to think of April Fool's idea, one of them was just like do reaction stuff, or find some way to make a pun on like the fact that it's a reaction channel. But I think this is going through. So we'll give it some time. We can stir it a little bit too. Give it the old swirl. This is the most important part of chemistry: is swirling things around. Hopefully not spilling. I failed at the most important thing of chemistry, which is just swirling things around. Yeah, swirling things around and feeling cool because you're like, ooh, chemistry, science. Look at me swirling this around. I can't even do this because I'm holding it with my non-dominant hand so that my other hand isn't blocking my camera so you can see my model. Whee. Okay. There we go. Yeah, see, that one's a bit clearer. We're doing all right. This is passable. It's not great, but it's passable. We'll combine them together, even though that might not actually be a good idea, but it's fine. Everything is fine. And now we filter into a new cup. Sorry, turtles, for the 35th time this stream. I will actually use 2 filter papers this time, I think, though, just to be extra sure. Again, it's probably not going to get that much, but it would actually no. Having other insoluble particles are bad because those will block the emulsifier from emulsifying. If I have a bunch of basically literally crushed up eggshells is like the same thing as calcium carbonate. If I have a bunch of crushed up eggshells in it, then those are it's probably gonna block the emulsifier from interacting with the cheese and making it smooth, making it deliciously smooth. All right, let's go. Oh yeah, that's looking better already. We wait for it to go through. Even with 2 filter papers, it should filter much faster because we've already done most of the filtering, right? The thing that makes filtering really slow is when you have a bunch of particles in it that you're trying to filter out. All right, I'll put those together, and that should be our sodium citrate. And I can mix it with the cheese, and we can get more cheese, and we can make some smoother cheese. Oh, come on. See it going. It's going. Is it clearer? Oh yeah, definitely clearer. I think my theory confirmed. It's just I was impatient. You'd be surprised how often that's the problem in chemistry.
how often the reason stuff in chemistry didn't work is because you were impatient. From every lab, it happens all the time. It's not just dumb amateurs like me. It's not just smart amateurs like not me. We're so close. Final stretch. You know what's crazy? I forgot to put up the chat overlay. And not only did I forget to put up the chat overlay, didn't even think about that. I didn't even realize I forgot to put up the chat overlay until literally just now. Isn't that amazing? Chemicals procrastinate. Yeah, they were taking a while. Probably because I didn't mix them at all. But that's okay. And the other thing is because the insoluble product, right? A lot of them were just stuck underneath the calcium carbonate, I guess. I don't know. That's harder to confirm, but I would suppose such a thing. I would suppose. Why is my model being all cursed? I would suppose such a thing. So this should be. Oh, how is it still not done yet? That's close. Everything's done here. Oh yeah, it's done. Everything's done. Everything's ready. Everything's fine. Everything's done. Yeet, yeet, yeet. There we go. This is our. It's still not perfectly clear, but it's good enough. This is our sodium citrate. We think. Hopefully, sodium citrate. Time to taste it. It tastes like the other one that I'm pretty sure was sodium citrate. So I think that's a success. I think we got some sodium citrate here. It doesn't. It's weird. It tastes like vaguely citrusy, but not. It definitely doesn't taste like citric acid does. It's interesting. It's weird. But yeah, we got our product here. It definitely doesn't taste like baking soda. So, well, maybe it does kind of taste like baking soda. Did I do an oopsie? Did I make the same mistake again? Hmm. Shit. It's just weird. It's so unlike like normal. It tastes so different from like normal food tastes that I don't really know how to compare it. I don't know how to compare it. I guess we can just add it in and see what happens. Right? Like surely nothing will go wrong if we just add it in and see what happens. I can cut up more cheese. Why don't I do that? The cheese I've kind of been left it out for a while. I mean, it's not like I've left it out the whole stream or anything. We'll add more cheese. There we go. I feel like that's about the amount I can add before the ratio of cheese to emulsifier is the same, and we're not actually changing anything for the first time where it worked. There we go. Fuck. Well, I guess there goes our product. God damn it. Shit, where's my angry face? How do I make an angry face? Angry, there we go. Enter. There we go. This is my angry face. I'm angry at myself for being an idiot. I'm angry. Meh. Meh. That's not even like cat noises. Meow. Meow. Meow angry. I spilled my sodium citrate everywhere. Okay, let's stop being angry. There we go. Back to normal. Where's OBS? Why can't I find OBS in this mess? There we go. Okay. Now, I mean, I guess this is probably sodium citrate here. I'll take the tiniest taste because I will be eating like half of it. Oh, holy shit! This tastes totally like citrate. I think it's literally just dense, and so it all sunk to the bottom. So me spilling it, I think we actually purified it. How? How? You so I made some of the cheese stuff, and it's not great, but it's definitely better than like normal cheeses. So I tried to speed run making another batch of sodium citrate, and then at the last moment I spilled it. I spilled it. I spilled it. I spilled it everywhere, and only a tiny bit was left. But this tiny bit tastes like
really strongly like sodium citrate. So I think what happened is the sodium citrate, is pretty insoluble. It's not gonna. It's sunk to the bottom. It's sunk to the bottom of the water, and me spilling it has accidentally just purified it because the dense sodium. So this is just like dense sodium citrate all sucked to the bottom. So when it spilled, this is the part that didn't spill. I have purified sodium citrate in the stupidest way possible. Oh my gosh. Well, I guess we can add it. Add it to our mix. Stir this around a little bit. I've added more cheese too, so hopefully that doesn't like offset it too much. But I have faith. I have faith. What I'll try to do this time is I'll like take it out while it's still melty, stir it, and put it back in the microwave. So let's go ahead and change this. I can give a new time estimate. We'll say 7 minutes. I think that's good. All right. Now I will run to the microwave. I'll put it over here. I'm too lazy to make the filter thing again. All right, Warpy and anyone else who is in chat, I will be back. Exactly. Task failed successfully. Task failed successfully. This is like going so much better than the tofu stream already. I'm redeeming myself. This is my redemption arc. It's redemption. All right, I will be back very, very shortly to microwave this.
back. And I think it might have actually worked this time, but it's a little bit hard to tell, so here it is. I've been trying to stir it a bunch, so I turned the microwave off and on and stirred it. And then I stirred it all the way walking up the stairs. It's like 6 flights of stairs. But it's kind of forming a mass. We're gonna have to see. We'll have to see how this looks. Oh, look at that. That is smooth, goofy cheese if I ever saw it. Holy shit. Oh my gosh, we did it. We did it. Let's go. My eye looks so weird then. Well, I'll try to hand out the water. I have to use fancy chemistry terms. Right? I'm not letting the water spill over. I'm decanting off this supernatant. Let's see. It's time for the taste test. It's probably still going to be really hot. Shit. That's okay. That's okay. Let's taste it. And when I already spilled some on my laptop, it's tasting time. Holy shit! Oh my gosh. Oh my gosh. It actually tastes like American cheese. It's bad because I hate American cheese and I think it's a crime upon humanity. I don't know what you expected from an Italian. But, it's, taste the yellow cake. Oh my gosh. Yeah, that's going to be the next stream is doing this but with uranium. No, it actually, I did not, I was holding out hope that this would maybe work. I can keep eating it. We did it. We actually did it. Oh my gosh. You can see here too, like it's just like a single homogeneous bit of cheese. Oh my gosh, yes. It's cheese. It's like what they're forced to say it by law, right? It's like cheese product, cheese food. That's literally what it is. You can eat it. Oh my gosh, it even comes apart like it too. Like, don't get me wrong, it's not perfect. It's not completely perfect. But it's really good. Go show a little bit of separation of like the fats and stuff. I mean, that happens when you like eat it. Oh my god. This is glorious. This is a glorious achievement. See, look, like even if you take apart where I've bitten into it, you probably can't see this on camera very well, but it's like homogeneous all the way through too. Oh my gosh. We did it. Mission accomplished. I'm gonna finish eating this little bit of it. Let's go. We did it. We turned gender fluid into cheese smoothifier. We made smooth cheese out of the gender fluid. Oh my gosh. Oh, look at that. Look at it. On the camera. Let's see. Look at that. It's so goopy. It's so goopy. If you just take a little bit of it, right, you leave it on the spoon for a little bit so it can cool down. Because, now it's not surrounded by hot stuff. It's surrounded by a fairly cold spoon and the air. It just turns into American cheese. This is amazing. Decant off the water. Oh, shit. There we go. Well, this is awesome. We're turning cheese into cheese. This is great. Well, as I eat this delicious piece of American cheese, so it's not delicious, but for American cheese, it's fine. As I taste this cheese, thank you so much to everyone who is watching this, or has watched this, or is watching the VOD.
or who has watched this and is watching the VOD again for some reason. Thank you so much. This is so good. Like, the thing is, this is actually probably tastes better than a lot of American cheese because it's made from like actual shit. It's made from like actual cheese, right? It's not like the normally American cheese made from the offcuts or whatever. This is actually pretty decent. Yum 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 yum. Well, thank you all so much for watching. I will see you at some point in the future. I do plan on at some point having like a. I do plan on soon having like a stream actual schedule, right? Where it'll be like these days of the week I will be streaming X. I don't have that right now, but I think I will soon. And of course, I'm also working on big long form projects that I'm super excited about. And I'm kind of it's taking all of the self control I have not to tell you about them because they're awesome, or they're going to be awesome. Then yeah. Thanks for watching. I'm so glad this actually worked. I'm probably the only one watching, so I'm the only one who has witnessed you make gender fluid American cheese. Why did that go away? Oh, did my phone die? Is that why that went away? I get perfect timing, I guess. Yes, thank you, Warpay. Thank you, Warpy, for standing by me. Your service is much appreciated. I guess if I'm doing this, I can put myself in the little spot like I was in the thumbnail. There we go. Whee! Well, thanks so much for Warpy and anyone. When I said this already, anyone watching the blah 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 blah. Bye bye.